now we move on to actual distance problems. Now let me do a review of other types of problems I've done in the past. In the past we've seen problems where there is a total distance given to you. When there's a total distance, I've said distance for one car or plane or train plus distance, rate times time, for the other plane, train, car, whatever, adds up to a total distance. We've also had some problems that involve the same distance. We're about to get to the same time. And that's where we have either someone catching up or overtaking another vehicle or a return trip. In that case, we've gone RT equals RT. We've also had some problems in which we have found the rate of both the current of a river as well as the rate of a vehicle, and we've gone distance equals rate times time for each of those boats or whatever we're dealing with. And when we've actually substituted the numbers in, we've sometimes had something like the distance is 90 for one. It's going with the current, so it gets an R plus a current for so much time. And then we have the same distance, perhaps let's call it 90 again, is against the current for some amount of time. And what we usually do here is we divide through by the time, and we have equations with R plus Z and R minus C, which we can add together to cancel out one variable. What we're going to do now is have some word problems in which instead of dealing with total distance or same distance, we're going to have total time or same time in the problem. Now, if distance is equal to rate times time, and we were to divide through by the rate, can you see how time is equal to distance over rate? So if I'm looking for total time, I can say time of one vehicle, d over r, plus time of another vehicle, d over r, adds up to a total time t. And for the same time, we can have d over r equals d over r. Now, every once in a while you get a problem where instead of adding, you are going to subtract. And in this pattern, usually it says, had we driven faster, we could have cut 1 hour off of our driving time. Well, if you cut 1 hour off your driving time, you have a difference of your times, which would then be 1 hour. I don't think we're going to see that right now, though. So we're going to just focus on these two formulas here, and we'll see in the word problems in a moment how those can occur. Here we go, turning the page. First problem. Boat travels 54 miles upstream in the same time. Notice how it says same time there. So I'm going to automatically just write d over r is equal to d over r. Make a notation for myself that the first one is going to be for upstream and the second fraction is going to be for downstream. Okay, the first time it travels 54 miles. There we go. In the time it takes to travel 66 miles downstream. Now the current is 2 miles an hour. Upstream, you're going against the current, so we're going to have r for the speed of the boat minus 2. And downstream, the boat is going to get the 2 mile an hour boost, so it's traveling at r plus 2, where r is the speed of the boat itself in still water. We're going to multiply through by the least common denominator, r minus 2 times r plus 2, which is basically going to be the same as cross multiplication on this problem. We're going to have 54, and after the r minus 2's cancel, we're going to have r plus 2 equals 66 times r minus 2 after the r plus 2's cancel. Distributing on the left, we have 54r plus 108 equals 66r minus 132. I want to get all the r's to one side, so I'm going to subtract the 54 off of each side, 54r that is. And to move the constants to the other side, I'm going to add the 132 to both sides right now. So the right side after subtracting will be 12r, and the right side is going to be 240 So dividing by 12, we see that it's going to be 20 miles per hour as the units. Whoopsie. 20 miles per hour. Okay, here we go with the next problem. Devin can cross-country ski at 5 kilometers per hour faster than his sister Chanel. Devin skis 45 kilometers in the same time. Again, we've got same time, so we're going to have time equals time, d over r equals d over r. Devin is going to be on the left, and Chanel is going to be over here on the right. And let's see what we've got. 5 kilometers an hour faster than Chanel. So if Chanel is skiing at r kilometers per hour, Devin is skiing at r plus 5. Devin can ski a distance of 45 kilometers in the same time that Chanel skis 30 kilometers for her distance. We're going to multiply through by the least common denominator, r times r plus 5, in order to cancel those fractions out. Let me move that down there. And here we go. On the left, we've got a 45 in the numerator. After the r plus 5's cancel, it gets multiplied by an r. On the right, we had 30. After the r's cancel, it gets multiplied by r plus 5. So we've got 45r equals 30r plus 150 after we distribute. Subtracting that 30r to the left, we have 15r is equal to 150, and r turns out to be 10 kilometers per hour. Now, looking at our denominators, this is r, that goes along with Chanel. And since we're looking for both of their speeds, r plus 5 was in Devin's fraction, so that means Devin is traveling at the 15 kilometers per hour in this problem.